All right, so the first thing you need to know is explanatory and response variables. It's basically which is your input and which is your output. How are you going to label the x-axis, the y-axis, and basically now we're going to have two sets of quantitative data instead of one set of quantitative data. So here's an example. To study the effect of alcohol on body temperature, researchers gave several different amounts of alcohol to mice. Then they measured the change in each mouse's body temperature 15 minutes later. So we have explanatory and we have response variables. So the response variable, you guys, always measures the outcome of the study. All right, so the response variable measures the outcome. And the explanatory variable may help predict the response variable. So what would you guys say is the response variable on this one? Okay, it's the body temperature. Good. So for this problem, our response variable would be body temperature. Okay, and what would be the explanatory variable in this one? Yeah, it's actually the amount of alcohol, but yes. Okay. So another example, we'll see if we can get this one for response and explanatory. The National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. So what would you guys say is the response variable? Yeah, it would be the stress. And what would you guys say is the explanatory variable? It would be the amount of debt and income. It's talking about both of those kind of at the same time, okay? So your debt income might help explain or predict your stress level. Things to look forward to in life, all right? So, a little football problem. At the end of 2011 college football season, the University of Alabama defeated Louisiana State University for the national championship. Interestingly, both of these teams were from the Southeastern Conference. Here are the average number of points scored per game and the number of wins for each of the 12 teams in the SEC that season. All right, so we have the points that they scored per game and the wins. We are going to make a scatter plot. So do you guys know how to make a scatter plot? Which one would you guys say is the response variable? Wins. Which one is the explanatory variable? Points per game. So does the response variable go on the x or y axis, you guys? The y axis, it's the output. Okay, think of it as the output, and the input is the x-axis. All right. So points per game we're going to put on the x-axis, and wins we're going to put on the y-axis. Do you guys think you could do this by hand so I can just show you on the calculator? Would you guys feel like you could make a scatter plot by hand? No? You need me to go through how to do it? All you guys have to do, don't forget to label your axes. All right, so this would be like points per game. And this would be the number of wins. And then you just got to space them and plot points, right? That's it. So I'm going to show you guys on the calculator in case you forgot. We did do this in Algebra 2. I'm going to see if I can blow this up so you can see it. What? I did. All right, you guys. So first thing you want to do is go to your lists and spreadsheets. Okay? And you're going to plug in the points per game. And then you're going to plug in the wins. So I'm going to pause this and you guys can do that. Or go to Zoom Stat. All right, you guys, everybody got data entered. Okay, go to Control Doc plus page. Okay, we're going to add data and statistics. Okay, Control Doc, add data and statistics. On the x-axis, you have to know which is your explanatory, which is your response. And so explanatory is the points per game. And then on the y-axis, you can scroll over here. And on the y, we're going to put the wins. I get this great graph. So what happens as points per game increases? The wins increase. Okay? All right, so in chapter 1, you guys, when we're describing a distribution, so when you're describing a distribution, that's one set of quantitative data, like you could describe a stem plot, you can describe a dot plot, you can describe a histogram. Now we've got two sets of quantitative data graphed against each other, and we use what's called DOFs for the shortcut for how to describe it. All right, so DOFs stands for direction, outliers, form, and strength. Okay, so direction is either positive or negative. So if you look at the slope of that line, you guys, is that positive or negative? Positive, as one thing increases, so does the other. So we would say there's a positive association. Between points per game and wins. Outliers. So outliers would deviate from that line by like a lot. So are there any teams who have like a ton of points but not a lot of wins or anything like that? And I would say no, there's not really any obvious outliers on this one. So I would say there does not appear to be any outliers. That word appear, right? For the form, you guys, it's always going to be linear or not linear on these. You could have a curved form, I guess. This one has a linear pattern, which most of them will. Yeah, you could have curved. And then strength is how strong or how linear is it? And this one I would say is fairly strong. We will talk more. If you guys remember the R value, that will tell us how strong it is. Closer it is to 1 or -1, the more linear it is. But we'll do that later. For now, you can just say it follows a pretty strong linear pattern. The more spread out, obviously, the less linear it is. And you guys will eventually use R value to talk about how strong it is. So to write this in one sentence, you would say there is a strong, positive, linear association between wins and points per game. So there's 3 words you're looking for: strong, linear, and positive. And then outliers can be a separate sentence. You either have them or you don't. Okay. Just to remind you guys, this is a positive association. This is a negative association. Yeah. Right? Just like your slope would be positive and negative. All right, so we'll do a lovely scatter plot here. We've got the Starnes family again that arrived at Old Faithful after it had erupted. They wondered how long it could be until the next eruption because they want to see the next eruption. So this is a scatter plot that plots the interval between consecutive eruptions of Old Faithful against the duration of the previous eruption for the month prior to the visit. So how long are they going to have to wait? Okay. So we're going to describe the direction of the scatter plot. So Cadence, what would you say the direction of the scatter plot is? I would agree with you. It looks positive. The longer the duration of the eruption, the longer we would expect to wait. Okay. And the form. Mac, what would you say about the form? Okay. Roughly linear with 2 clusters. So we haven't really talked about clusters, but if you look at this picture, we kind of have a cluster of points and a cluster of points. And so the clusters indicate that in general there are 2 types of eruptions. There's kind of a shorter one that lasts around 2 minutes and a longer one that lasts around 4.5 minutes. All right, how strong is the relationship? Elizabeth, what's your guess on that? Okay. Okay, we'll see. Fairly strong. So the points don't deviate much from the linear form. So you guys, it doesn't even have to be that linear, right? And you can say that's fairly strong. Those don't exactly line up perfectly, but it does have a linear form, okay? So you can still say fairly strong. And are there any outliers? There's a few possible outliers around the clusters, but there aren't many, and potential outliers are not very distant from the main clusters, but like maybe those, okay, we don't know for sure, could be an outlier. What information does the Starnes family need to predict when the next eruption will occur? So you guys, in order for them to predict how long they're going to wait, they have to know how long the previous eruption was. Okay, and that's it for the scatter plot. Oh, I forgot to